Hello everyone, my name is Metan Bergin and today I'm going to present you my Physics 102 project. In this experiment, I investigated eddy currents and Lenz's law by measuring how long a magnet takes to fall through vertical tubes made of different materials. The purpose of this experiment was to show that the fall time changes depending on the material of the tube. When a magnet falls through a conducting tube, such as copper or aluminum, it induces eddy currents in the tube, and according to Lenz's law, these currents create a magnetic field that opposes the motion of the magnet, so the magnet falls more slowly. To compare this clearly, I also used PVC tube, which is a plastic and non-conducting tube, as a control material. Since it is non-conductive, the magnet falls much faster and behaves much more closer to normal free fall. So overall, this experiment demonstrates that better conductivity causes stronger electromagnetic braking, which increases the fall time of the magnet. Here I am measuring the lengths of the tubes used in the experiment. I used two different lengths to compare how the fall time changes with distance. This was important because the theoretical model predicts different scaling behavior for conducting and non-conducting tubes. In this part, I am measuring the mass of the magnet. I also measured the magnet dimensions before the experiment to keep the setup consistent. Using the same magnet in all trials was important for making a fair comparison between the different materials. Here, the magnet is falling through the 65 cm copper tube. This is the slowest motion among the materials because copper has the highest electrical conductivity. As the magnet moves through the tube, it induces strong eddy currents, and according to Lenz's law, these currents create a magnetic field that opposes the motion of the magnet. In this video, it takes almost 44 seconds to reach down, and it is 240 fps slow motion camera. Therefore, it is approximately 5.5 seconds through the copper tube in 65 centimeters. And this is the 65 centimeter aluminum tube. The magnet is still clearly slowed down, but not as much as in copper. That is because aluminum is conductive, but its conductivity is lower than copper, so the electromagnetic braking effect is weaker. And here the magnet falls through the 65 centimeter PVC tube, and PVC is non-conductive, so it does not produce significant eddy currents, and because of that the magnet falls much faster and behaves much closer to normal free fall. And this is the 30 centimeter aluminum tube. The fall time is shorter here because the tube length is smaller, but the magnet is still slowed down by electromagnetic braking. This part helps us compare how fall time changes with tube length in a conducting material. This section shows the main results of the experiment in the report. I recorded multiple trials for each material and tube length, then calculated the average fall times, average speeds, and the scaling ratios. For PVC, the results are closer to the relationship T proportional to the square root of L. This is what we expect for near free fall motion because there is almost no electromagnetic braking in a non-conducting tube. So for PVC, the time does not increase linearly with length. But for aluminium and copper, the results are much closer to T proportional to L. This means the fall time increases almost directly with tube length. That behavior is consistent with motion under strong eddy current braking, where the magnet moves closer to terminal velocity inside the conducting tube. And these graphs summarize the average fall times for each material and tube length. The results clearly show the expected order. Copper has the longest fall time, aluminum is in the middle, and PVC has the shortest fall time. Overall, the experiment successfully demonstrates the effect of eddy current and Lenz's law on the motion of a falling magnet.